Okay, good afternoon guys. Good afternoon Paris. How has the conference been so far? Good. Seen some really excellent talks. Thank you Bruno for the really nice talk. I am going to do a talk today about two topics. I'll talk about exploit development in general. So we'll be talking about a plugin, and I will also going to talk about Project Quebec. So let's get started. Who am I? My name is Peter van Eeckhoutte. People might know me by my nickname, Corland Coder. I am the founder of the Corland team. That's our website. We basically are a group of people who share the same interests. We do vulnerability research, exploit development. We published a series of tutorials on exploit development, so that's what we do. You can follow me on Twitter. I'm not one of these certifications. I'm not anonymous either. But I have a good reason to stay in the room, because I am between you and the next coffee break. So, and by the way, this will be more or less a technical talk. If you guys have questions, please just raise your hand, and we'll just make it as interactive as possible. Maybe we should just try. Maybe you can all raise your hand, see if the system works. Everyone? Come on guys, this is not a morgue, okay? Yeah, okay. Good. Earlier today I had some talks with some people, with some attendees, and some people asked me the question, Peter, how do you manage to do all of this? I have a day job, I don't have a security job, and I still manage to do all of this, and where do you find the time? Was one of the most commonly asked questions. So, if you look at time, and if you look at the word time or the concept time, what do you guys associate time with? If you hear the word time, what is the first thing that comes to your mind? Fast? Money? Yeah, well, I summarized a few ideas. There's not enough time, flies by, it's universal. Money, stress, hard to manage, deadline. Most of these things have like a negative annotation. It's a little bit negative. In fact, unless you are very fortunate, what we do with our time is usually not what we would like to do. We all have a family to support, we have maybe a mortgage or a car to pay or whatever, and we would like to play all day, but we have to go to work. That's a fact. And if we look at what we need to do, we probably have 25 hours worth of work, and we only have 24 hours of time. So finding a balance between those two is kind of painful. And I think that summarizes it. There's not always a perfect match. Now, I mentioned the word pain. If we think about pain, what is the sound of pain? Ouch or right? So, the more unbalanced, the more pain there is. So the more pain, the more And we all know what happens in real life. That leads to a buffer overflow. And that looks like this. I don't know, are there any exploit developers in the room? What kind of overflow is this? It's an exceptional handler overflow, as you can see. So, what do we do to fix the problem? We try to multitask, or we try to automate things. So before we leave to work, we set up our cluster with fuzzers. We have some scripts that automate all that, and it just starts fuzzing the applications. And we've also set up some scripts. As soon as the fuzzer finds something, it's going to send us a message on Twitter or an email, or we have a bot that DMs us on IRC, whatever. So bottom line, we try to automate that process. And then in the evening, when we get home, we have like this nice script that turned all the results into this, right? Yeah, that's what happens, right? I wish this was the case. It's not. We usually have to do some manual work to actually turn our results into an exploit. And the fact is, it takes time. If you want to write an exploit, it usually takes some time. Now, we don't have enough time, so there's like a big problem between what we have, what we want to do, and the available time. And if you look at this concept or this idea in a professional environment or in a pen test environment, we usually are faced with a deadline, so we don't have a lot of time to actually do what we want to do. So, our goal is to be able to do fast and reliable and efficient exploiting, make it as fast and good as possible, which should give us more time to do the harder ones, but we don't have it. So, frustration. And what is the result, or what is the answer or the solution to this? We also need to be able to automate the exploit development process. And we can use plugins. And we're lucky. There are plenty of plugins out there. There are way too many plugins out there, in fact. If you're building an exploit, you'll probably need at least 2 or 3 of these exploits. I personally, I still was not happy. I started using plugin A just to fix a certain issue when building an exploit, and then I needed another plugin, but that plugin required a separate debugging environment. I mean, it's still a mess, and I was still not saving the time that I wanted to save. So I was still frustrated. So I wanted something better. I wanted something that would work just within a single debugger environment, a single plugin, one that is smart, and was going to give me reliable results. So I wrote something myself. PVE find ADDR. Yeah, I know, it's not the best name, but we'll come to that later on. Maybe just for statistics, has anyone heard about this plugin? Raise your hand. See 2, 3 people. Someone in the back. All right. Anyone involved with exploit development in general? Raise your hands. Oh, there are less than the guys who heard about the plugin, so that's something wrong here. But anyways, now statistics are not that important. If you look at statistics, about 80% of the statistics is based on fiction anyway, including this one. And pie charts, I mean, most of the pie charts look like a butt anyway, if you look at it. So, anyway, back to the plugin. So, I wrote the plugin back in September 2009, and its initial goal was to find addresses. Hence the name, find ADDR. My initials of my name is PVE, so PVE find ADDR or address, whatever. That has a little bit over than 5,000 lines of code today, and it's aimed at, it should be run when the debugger is attached to the application at crash time, so you get the correct context to run it in. There's a little problem with this plugin. If you let it run, you let it search for addresses, don't touch the debugger or it will die. So, but that's just a little bit buggy. This is its general usage. The project page, so you can download the plugin, is available for free. And these are the basic commands that are available. So that's a lot. I will look at some of these commands right now. So that's all nice. A lot of theory. Let's have a look at what it actually does and how it can help us speed up the exploit development process. So we'll look at a simple example. Let's say we have a saved return pointer override. So when the function ends, we gain control over EIP. And in the most common case, we will try to override EIP with a jumper to jump ESP, for example. So, but in general, the tool is not just going to look for a pointer to jump ESP. You can search for a jump to any register. So, without the plugin, this is what we would do. We can either use the debugger built-in search, right-click, search, and find jump ESP. It will find one pointer at a time, and it will give you the pointer from the currently loaded module or the module that you are looking at right at that time. You can also use a command line tool, a script, outside of the debugger. You'll have to tell it what modules to query, and if it supports regex, it might actually give you good results. Or you can use a plugin. There's plenty of plugins available. It's probably going to query all or maybe just one module. So you'll get a bunch of results and you'll still need to figure out which one you need to pick or which one will work. So you'll probably end up with more frustration. What are the issues with this? Well, first of all, we have to select, in most cases, we have to select the modules that we want to query. Or it will just look at all the modules. But there's a problem with that. In most cases, we don't want to look at all the modules. We want to skip certain modules, especially the ones that are not going to provide with reliable results. For example, the modules that are ASLR enabled, well, first of all, you'll need to have a way to tell if the module is going to be ASLR enabled before you can actually say, okay, I'm not going to look at that module. It takes a bit of time. You'll probably end up using another tool or another script to do that. An often overlooked issue with modules is the fact that they might get rebased. And if they are rebased, it will lead to the same problem. It won't be possible to find a reliable pointer from that module. So you want to skip those as well. And it's not easy to determine if a module is rebased unless you actually load it in the application and you look at it. And a third issue is operating system modules versus application modules. We ideally, if we want to build an exploit that is transportable, that will work on different versions of either the operating system or patch levels of the operating system, you want to avoid using operating system modules. So you'll probably have to manually exclude those modules from the search. And then it returns pointers. Now, what if we don't want pointers that meet certain criteria? If you are writing an exploit for a string-based overflow, we probably don't want pointers that have null bytes. So once you get all the results, you'll have to start filtering again, exclude all the ones that don't meet the criteria that you need. What if we want pointers that are just ASCII printable? And if you look at the output, you'll just see, some hexadecimal values. So you have to start figuring out, okay, is this ASCII printable or not? It takes time. Now we are wasting our time. And if you're using a script that doesn't run within the context of debugger and your module is packed, it's not going to produce any good results either. So that's also a problem. So, bottom line, anytime I see anyone using the built-in search in the debugger, it's either a ninja or he's just pushing his luck and hoping for the best and see if the pointer works. And it's also a fact, a lot of the plugins, they are still outdated, they are not maintained anymore. That's also an issue. So, running searches within the right context is really key. It's really an important component of being able to produce reliable results. So that means that, and it's my personal opinion, it means that you should be running searches within the debugger environment, or at least within the environment where your modules are loaded at the correct address, and that's basically what the context is. So what does PV find ADDR do with that respect? Well, it will automatically filter out modules that are not going to produce any reliable results. So we already win some time here. It's also in the output, it's going to indicate whether a pointer has a null byte or if the pointer is ASCII printable. So you can use grep, for example, and there's a link to the grep utilities for Windows. You can easily look in the output and filter out the ones that you need or you don't need. It will also ignore operating system modules if you tell it to. It will actually look for the bytes and not for the instructions. So that means that if there is like a longer instruction and it contains the opcode of the instruction that you are looking for, it will find it. It's not just going to look for the assembled instruction. Well, I think most of the other tools do that as well. And it's not just looking for the jump. It's also going to look for a call. It's going to look for a push.ret and some other combinations. So I'm not sure if the other tools do the other combinations as well. And that's just a command. It's a single command. Very easy, takes a little to run, it writes all the output to a file, and we win. So let's put that to practice. If we use that concept and if we compare this plugin with some of the other tools or the other search techniques that are available, we can come to these conclusions. I just tested it on a very popular music player I bet everyone uses on their computer. No? Okay. So there was an exploit in that application when opening a playlist file. In order to gain, or in order to be able to start executing a payload, we needed a pointer to a jump ESP. And these are the results. If we just use a script that searches on all the modules, we end up with more than 200 pointers. If we just limit it to the application modules, there's about 100 pointers. If we also skip the ones that are not going to be rebased, we end up with 5 pointers. And PV find ADDR will just return 1 pointer, and it's the only one that actually will be reliable. So if you use this tool, you get the right and the correct answers right away. So next step in the exploit development, once you have a good pointer, okay, where are we going to put it? The most commonly used technique is using a cyclic pattern. We basically fill our buffer with a cyclic pattern. Every 4 bytes in that pattern are unique. So if we overwrite EIP, we should be able to quickly find the offset so we can overwrite that location with a pointer to a jump ESP, in short. So we can use the tools available in Metasploit to do this. We create a pattern of a certain length, we write it to a file, we copy it, paste it into our exploit, trigger the crash, and when we overwrite EIP, we get a value, in this case df2d, and that refers to offset 2496. Perfect. But we can do better than that. If we are using a cyclic pattern, or want to use a cyclic pattern, first of all, we can just create it with the plugin. We don't need Metasploit, a second box, whatever. We have the tool ready available inside the plugin. We can create the pattern. We can also find the offset. But once we are, or since we are using a cyclic pattern, we can actually do a lot more with it. We can actually look for that cyclic pattern in memory, and it's going to indicate where the locations are where we can find our payload. And that, in fact, is an important step in the exploit development. You should enumerate all your options or your primitives before actually building the exploit. There might be a maybe less obvious way, but a more reliable way to jump to your payload. And if you are not searching for your options, you may miss that opportunity. So that's an important step. And there's a single command to do it. So if you crash the application with a cyclic pattern, you just run pv find ADDR find MSP. It will give you the offsets. It will show you all the locations where it can find the cyclic pattern. It will look at the exception handler chain. It will look to find pointers to the cyclic pattern on the stack. So it's going to do a lot of searches, and it will provide you that in a single view. So that's easy. And I have a free tip of the day. If you ever write your fuzzers yourself, it might actually be a good idea to use a cyclic pattern instead of just A's, because you win time. When you trigger a crash with the cyclic pattern, you can just run find MSP, and you will get a lot of information right away. So I already explained what it will do, and it's clearly a win. It will save you time. And by the way, also important, I didn't mention that in the previous slide, so it's not only going to look for the cyclic pattern, it will also detect if your pattern was converted to Unicode. Might also be another way to gain code execution. Second example, exception handler overrides. So if your buffer overrides an exception handler on a chain, and if you can trigger an exception, it will jump to the pointer that is in the exception handler field in the exception handler record. So when the handler actually kicks in, there is a pointer to the same record at ESP plus 8, and a common exploit technique is to override the handler with a pointer to a pop-up red, for example. So we all know when building an exploit for this type of overflow that we should avoid using pointers from modules that are safe, structured exception handler protected, because we can't use them. And there might be a similar issue like the ones we had when searching for a jump to register in this case as well. We'll first have to look for the modules, then we have to select them, maybe copy them to another system, run the script against it. I mean, that's way too much for me. I just want something that runs, that automatically filters out the modules, that skips the one that are ASLR or rebased, that also looks at the criteria of the pointers itself, and that gives me good results. So, in that respect, this is what the plugin does. There are like 4 ways to look for alternative pointers, and you have full flexibility. If you are writing an exploit for XP where there is no ASLR, you can still query the modules that are ASLR enabled but not rebased. So you have all kinds of flexibility to actually give you a list of good pointers. And there are a few other options that you can use basically in every search. You can automatically exclude pointers that have null bytes, or if for whatever reason you only want to query a specific module, you can just specify the module on the command line. So that's perfect. Now, if we combine all that knowledge, we have a tool that will look in memory and find offsets based on a cyclic pattern. It will look where your payload is. It can look for pointers. There's a lot of information that it can gather. Maybe we can take it one step further. And I list 3 steps to victory. First, you trigger a crash in the application using a cyclic pattern. Then we just run this command, suggest. And what suggest will do, it will automatically gather all the primitives, it will take all the knowledge, and it will actually suggest something. And that should lead to victory. So I prepared a little video to demonstrate the suggest function and see what it can do for us to speed up exploit development. So there's a bug in a popular SCADA application. It's a stack buffer overflow, it's a remote overflow, so you just send the packet to a server component and we overwrite something on the stack. So let's see. So I'm just going to launch the application. It's running. Yes. Next, I'm going to attach the debugger, immunity debugger in this case, to the application. So it's listening on a port. Attach, and we continue to run. So we have a running environment. We create a pattern of 5,000 bytes, and we will use that pattern to crash the application. So it creates the pattern, it writes it into a little text file. We open the text file, copy the string, and now I cheated a little bit. I already prepared like a little framework that has the header that needs to be sent. We'll just fill in junk with 5,000 bytes, cyclic pattern, and we will send the header with the junk to that port. So that's the only thing that the script does. Very simple. So, application runs. It's kind of weird to see it type, and I'm not using my hands. But so, here we are. We triggered an overflow, tries to write beyond the end of the stack, and if we look at the end, we see our cyclic pattern. So, if we now run pv find addr suggest, it's going to do a lot of stuff. Well, let's scroll up, let's see. So it looked at all the registers, it looked at all the places where it can find the cyclic pattern, it looked at the exception handler chain, and it determined that we have overwritten one of the chains. It also shows pointers, and then it basically suggests a payload. It shows the exact structure on how to build the exploit. So let's change this. Let's change this. we'll just use a bunch of A's, 510, because that was the offset. Anyone familiar with building an exception handler overflow? This is a short jump forward. Okay, we need a pointer to a pop-up red. So, and actually if you look at the output, yeah, it's out of the screen, but it will actually show you the command that you need to use. So I'm looking for a pop-up red. I don't want null bytes. -O means I don't want to use operating system modules. -I means no rebase modules. And it's just going to run. And I'm just showing this in real time. I didn't cut, so it will take a little while. We will talk about time later on. But you are sure that whatever it's going to return, that will be reliable. So we'll just wait a few moments here. Exciting. You can go out and get a cup of coffee. So. So as you can see, it's trying a lot of combinations. And there we are. It found 590 addresses. That should be enough. So we'll just open the log file. It shows all the modules with all the properties. And we'll just take the first one that we see. We copy it, go back to the exploit module, and we are going to put it in the exploit. Okay, what else do we need? Well, we need shellcode, of course. So we'll quickly use Metasploit to create some shellcode, some easy calculator shellcode. And we'll use null byte as a bad character. So we'll let it create. Takes a few seconds. There it is. So we just copy the shellcode and we paste it in the exploit. That's it. So we save the file. No. We use the 5,000 bytes pattern. We want to make sure that it's going to trigger an exception, so we'll just add 4,000 bytes. Complete the buffer, so the header, 510 bytes, our exception handler record, shellcode, some more junk. So, and that reflects what PV find ADDR has actually put in the output. So we'll save the file. We'll close the debugger. We'll just start the application again. And again, all of this is real time. I'm not cheating. Okay. So application is running. The Python script is on the desktop, so we'll just double click it, we'll run it, and there we are. So that's all it takes to build an exploit. Thank you. Any questions so far? No? Perfect. Let's move forward. Bad characters. That is also a big issue. If you want to build a reliable exploit, you really have to figure out what your bad characters are. You might be able to produce shellcode that works, but if it's not based on facts, if it's not based on the research that you did to actually find all the bad characters, you may have been lucky. And if you happen to be lucky all the time, maybe it should be a good time to start playing the lottery. It might actually provide you with some money. So you can guess. Sometimes it is possible to guess. If you just think about the payload, if you are, for example, attacking a web server, maybe you can already figure out what the bad characters will be. Maybe it will be just ASCII printable. Maybe a backslash or a forward slash may change the way the payload is processed by the application. So you can make already, let's call it an educated guess on what the bad characters will be. But if you're not sure, and especially if you're attacking an application that has its own proprietary format, you're not really sure. For that reason, there is an option, a function in PV find ADDR that will actually help you to build the exact list of bad characters. So what it will do, you basically have to build an array that contains all of the bytes, so from 00 to FF. And you put it in the payload, so in the exploits that you're going to send to your application, and you at the same time, you also write that same array to a binary file. And then you crash the application with the payload that contains the array, and at crash time you just run the compare function and you feed it the array that was written to a file, you feed it as the input. So it's going to take the array and it's actually going to search in memory for that array, and it's going to compare each of the bytes and see which one is corrupted. So if there is a corrupted byte, you're more or less sure that that one is going to be a bad character. You can just take it out, you exclude it from the array, and you repeat the process until all of the bytes in the array are still there. So that's just a technique to find bad characters. I'm sure there are other techniques to do this, but I just wanted to have something that works. And as a bonus, it's not only going to look for that single array, but it will also locate all the copies of that array in memory. So it might actually tell you that there is a copy that is not that is not corrupted. Maybe there is a copy on the heap somewhere, and we are looking at the stack, and it has all kinds of corruption, so maybe it's simply easier to just return to the heap. So it will show you that information. It will actually help you that. Unicode exploitation. For a long time, a lot of people thought that Unicode was not exploitable. Okay, it's not easy to exploit, but with the right tools, it's perfectly doable. So it's important to understand that Unicode is not just nulls that are inserted between your bytes. What you see in your payload is actually the result of a conversion or a transformation by a function. And that transformation, it's not always going to result in null bytes. Sometimes certain bytes will be expanded to two other bytes that are not nulls. So just looking for stuff that is 00 byte, 00 byte, it's not enough. So, and to be honest, I haven't seen a lot of scripts that deal with Unicode, and I certainly haven't seen a lot of scripts that will handle those transformations. So that's why I included the search. And every single search operation in the output, it will actually indicate if a pointer is Unicode. It will also indicate if that pointer is a transformed Unicode. So you can actually use the Unicode equivalent, and it's going to get transformed during the exploit into the correct pointer. So that is really valuable information. And as a test case, I think it was about a year ago, I was just browsing on exploit.db. We all got the website as our homepage. There was a proof of concept for another music player, and I just liked to write exploits for fun and just, practice leads to perfection, so you just, continue to practice. I noticed the proof of concept, and it was about 2 weeks after the proof of concept was posted, and I noticed that there was still no exploit for it. So I thought, okay, let's take a look, and I looked with the conventional searches, and I found out that there are no Unicode pointers. So I figured, that's probably the reason why there is no exploit. So I ran the same search with PV find ADDR, and it actually found 3 transforms. So if you don't use the right tools, it will give you a sense of, okay, this is just denial of service, it's not exploitable, while it is perfectly exploitable. So we just wrote the exploit and we published it on exploit.db, so you can take a look. And another example, I'm not trying to brag, actually one of the guys in the Corland team, he participated in an offensive security exploit weekend where they were given a challenge to write an exploit for a PDF reader. It was a Unicode exploit. The idea was to spend the entire weekend building the exploits. Well, they had to stop the game after a few hours because using the right tools, it just went like that. And of course, PV find ADDR, it would be silly if it can't just find something. Of course, there is find functionality in the debugger. The advantage that PV find ADDR has that it will nicely list all the results right underneath each other, versus if you do a find in the debugger, it will just jump to that location and then what? So it's kind of nice. If you're, for example, building an exploit that contains an egg hunter, this is just a way to see if you can find the tag somewhere in memory. So some other options of the plugin. You can assemble instructions. You can calculate the offset between two locations or between a register and a location. I know that you guys can do that by hand, and maybe some of the people in the crowd can actually calculate hexadecimal from the top of their head, so sorry for you, but I mean, there's a function for the other ones. You can show some information about an address, if it's what module it belongs to and some other properties of that address. You can show a list with the modules, you can show the ones that are not ASLR enabled, and so on and so forth. So we have a lot of good functions and good commands to help us speed up the process of exploit development. And if you're still not impressed, there's more that we can do. We already have ways now to bypass ASLR, to bypass protections against exception handler overrides. What about DEP? I think the most common technique to bypass DEP is using return-oriented programming. So about a year ago, I think, yeah, mid-June 2010, I released a function, a public function to create gadgets. Anyone familiar with building ROP exploits, that probably is one of the first things that we do. And so, yeah, happy birthday, we're a year old, so perfect. It's slow, it's one of the comments that I received from people in the audience. It's slow, but I mean, the results are good. So you might actually spend not just a coffee, but an entire meal. Sometimes it takes a few hours to create all the gadgets. If you compare that to all the recently released scripts that will actually provide gadgets, they create gadgets in just a few seconds. Just remember, I don't have to specify any modules. I don't have to think about ASLR or rebase, because the module will take care of that. So it's kind of trade-off, but I mean, then again, I agree, it's slow. And of course, all the resulting pointers, they all have the same features, so they will also indicate, do they have null bytes, or you can actually tell it to ignore null bytes. We can easily pick out the pointers that are ASCII printable, and so on and so on. So lots of features. It also does opcode splitting. So if it finds the first gadget, it will actually try to walk back in the opcode bytes and see if there is another gadget. So that's also one of the reasons why it's so slow. For each instruction and each gadget, it's going to walk back, cut it again. It takes time, but at least it will provide you with as much useful gadgets as it can. So that's good. By the way, if you just look at the timeline, when we published the tutorial about ROP and when we released the tool versus the amount of publicly available exploits, could be kind of coincidence, so check it out. So to summarize, I hope I have been able to convince you that PV find ADDR will actually buy you time. It will find accurate information, which is very important. It will also automate certain tasks. It will probably do even more than what you usually do manually, so that's a good thing. And one of my friends, Wim Rimes, in his talk at Black Hat earlier this year, he gave a really interesting talk about visualization. So he learned me to visualize. Without the plugin, we end up with frustration. And if we can buy ourselves time with the plugin, we have time for fun. So here you go, Wim. Questions so far? No? Okay. So let's go to the second part of my presentation, Project Quebec. there are a few things wrong here. First of all, when I started developing PV Find ADR, I was just writing it as like a private tool, a tool for myself. It was not really designed, or, you know, designed is the right word. It wasn't really designed to do what it does today. So I just added functionality over time, and I'm not really a good programmer, so I agree. I don't know if anyone of you actually opened the file and looked at the code. It's a bit messy and kind of reusing blocks of code, and sometimes I'm using functions, and other times I'm just doing inline, you know, all the bad things that really bad programmers do, but I mean, yeah, it's a fact. So this is what we have today. I forgot about the indentations, so I started using space indentation, and I wasn't really consistent, so I should have used tabs, but I mean, yeah, it's a big mess, it's a big mess. The good thing is that everything works, but I agree, it's awfully slow for certain tasks. Some of the tasks are not too bad, but especially if you look at Rob, for example, it's really slow. So the reason why it's so slow is it's actually going to perform the search in the entire memory space, and then when it gets all the results, it's going to do the filter. So it's then going to filter out anything that is rebased or ASLR, or if we don't want null bytes, it's only going to apply the filtering afterwards. So that's kind of one of the reasons that it's so slow. Second reason is that the IMMlib search functionality, so IMLib is the API exposed by the debugger, it's not one of the most performant searches either. So I'll call it suboptimal, it sucks. I mean. So another issue that's based on good feedback I got from the community is when you're writing, or when you're using the same machine, the same debugger to write exploits for multiple applications, you discover that when it writes the output to a log file, it writes it to the same folder, basically overwriting the log file you created maybe a few hours before, and you just rip out all the work you did. So that was kind of painful. And also, and that was also a request I received from the community, it was hard to exclude certain modules. Why would we need to exclude? Answer is really simple. Think in terms of shell extensions. What if you install the tool on your machine, it loads the DLL on every single process. Of course, we don't want to use pointers from that module. They will be unreliable, so we need to have a good solid way to be able to exclude those modules from all the searches. So these are just a few issues that we had with, or that we have with PV Find ADDR. Boo, I know, I agree. So, Project Quebec, it's actually the working title for an effort, a Corland team effort to rewrite the entire plugin. And we started the design phase back in February. The development, I mean, I completed a few lines of code yesterday, so we are still writing some code and still fixing some patches. The key, and that's the message that I want to bring today, the plugin will get a new name, and I hereby declare PV Find ADR officially dead. So anything that we've seen up to this point is dead, it's gone. Sorry. So please take a few moments to mourn about PV Find ADR. Yeah, it was fun, but I have good news as well. There's a new one, and as I said, we renamed it, and the new one is called Mona. So that's the new version of PV Find ADR. It still uses the same concepts and the same ideas and the same technology, well, maybe not the same technology, but the same concepts and the same techniques that it used in the previous version to provide information. So not everything is lost, of course. And it was professionally redesigned, and as you can see, we really did a professional job. We tried to do, you know, the ways we should do it. So, and it was actually a team effort. I mean, PVE was more like a private project. This is really the result of some great teamwork. So I just want to mention the guys that actually participated in the project. So let's Let's have a quick look at all the improvements in the new version. First of all, I think this is a really important improvement. It's easier to pronounce. It now has a help for each command. I mean, this might sound silly, but in the previous version, if you wanted to know what the command line arguments were for a certain command, you had to run the plugin without any arguments, and you got like a 3-page list with all the commands. You have to scroll back, look for the function. The key is to save time, and then I write something that actually takes time. I didn't like it, so we wrote help for each command. It's kind of nice. We also have a config file. We'll look at that in a moment. We have a few global options. I'm sure you guys will like the global options. We'll talk about it. Performance. We've really worked hard on performance. I'm going to show you some statistics in a few moments. There is a major improvement in terms of interaction between the various functions and classes, and that will lead to some interesting results. We'll show a demo on that. And I don't know if you remember in the output when we run the suggest, it showed a Perl output. Well, we like Metasploit now, so we decided to show all the output in Ruby in something that would be easily copy-pastable into Metasploit. So we'll see what it looks like in a few moments. These are the functions that are added into the plugin today. If you look at the first one, SEH, exception handler override, remember the slide that I showed a few minutes ago? It had like 3 or 4 or 5 different commands to search for exception handler. Well, we figured it doesn't make any sense to give you all the commands and you have to search or pick the one that you need. No, we just need one function, and we'll use some of the options and command line arguments to really fine-tune the search and to make sure that the results are fast and accurate. So, the config file, it's actually just a simple text file that is saved in the immunity program folder. It's trying to solve 2 of the issues that we addressed. So first of all, there was the issue that the output is written into the immunity program folder, basically overwriting the existing file. So what we did, we just made a working folder configuration where you just point it to a separate folder, and you can actually use %p, which will be replaced at runtime with the process name. So if you create a folder logs, it's going to nicely create subfolders so you know where the output belongs to. So I think that's helpful. By the way, you can also use %i, and it's going to include the PID of the process, just in case you need it. We also needed to have a way to exclude certain modules, so we also made an option, excluded modules, and you just specify the modules, and these will be ignored in every single search. So this way you can exclude all your virtual machine addition tools and your SVN shell extensions, whatever. So you just put them in the list. They are stored, and they are stored permanently, so they will be applied to every search regardless of the application that you're working on. The global options, they are also nice as well. Global options will allow you to perfectly fine-tune the search results. We still support the backwards, well, we still provide backwards compatibility. -n meant I don't want pointers with null bytes. -o referred to the fact that we don't want pointers from operating system modules. But in fact, there is a lot more that we can do. So -cm means criteria for modules. We can now nicely say I want to include or exclude modules that have one of those criteria, and just use comma and the next criteria, so you can make your exact, precise target for your search. So if you, for example, want to search for pop-up rats, you can, and you want to search in modules that are ASLR enabled, because you're working on XP, for example, this is the command to do it. Very easy. If you want to limit your search to one or more modules, you can just specify them at the command line. You can use some wildcards. So we didn't have that functionality in PVE. You could only search in one module. Now you can specify multiple modules. I think it just makes sense to do this. So it's not much we can tell about this. Pointers are data. I'm not sure if you guys realize, but in most exploits, there's only one pointer. The one that we use to gain control over the flow and jump to the payload. But, and especially if you're looking at return-oriented programming, a large piece of our payloads are pointers. So that means that all the bad characters and the entire philosophy around bad characters, they also apply to pointers. So that means that we need to have better ways to look for pointers that meet certain criteria. So this is what we did. We provided an option -CP, and you can specify one or more of these parameters. So if you're looking for ROP gadgets that are ASCII printable, there you go, -CP, ASCII print, and you will only get pointers that are ASCII printable. So that's kind of nice. And Unicode, by the way, I really had a look at the transforms, and I discovered that the transformed routine in PV find ADDR, it was only looking at the last 2 bytes. So the new one can also look at the first 2 bytes. I don't know why I didn't do that, but current version, it will look at the exact transform. So that's just as a side note. This is nice, but it's not enough. We can actually do this. We can do -CPB and provide a list with bad characters. If we already know that it needs to be ASCII printable, but 20 hex, which is a space, is not allowed, we can just do this and add x20. So it's going to exclude the pointers that have a 20 as byte in the pointer. So you should be able to get an accurate list of pointers by using these criteria. And the good thing is, the more criteria you provide and the more specific your command is, the faster the search will be. Versus PV find ADR, it will be vice versa. It would take more time to filter. We are doing things differently now, so it's a lot faster. So that's just an example of how to use it. Okay. Performance-wise, we also really paid a lot of attention to the way we are handling the searches. So I think we all agree, at least I agree, that the old version was a time saver, but we really tried to do our best and to listen to the feedback that we got from the community to make it faster. So we are not using the IMLib anymore for searches. We are just looking at pages, enumerating pages, and doing some splits and some nice actions on the pages, and that results into a lot faster results. And if you combine that with the fact that you can be really specific in your searches, I am sure that it's going to give you accurate results and a lot of results in a very short amount of time. So I think that's important. It's also going to do smart searches. If you're looking for start with null pointers, it's not going to search in modules that don't start with a null. So it's going to limit the search right away. So it's smarter. And also, if you only need 1 or 5 or 10 pointers, you can just limit the number of pointers and it's going to stop the search right after. So it's immediate. So let's look at the statistics. A speed comparison between PV find ADR and Mona, the new version. So we just did 3 searches against this application. So we looked for, we did a search for jump ESP, for pop-up red, and we also generated a full ROP gadget routine. So as you can see, search times are at least 10 times faster, sometimes they are about 20 times faster. So I think a lot of you people will be happy about that. So let's take a look again at the same application that we looked before. So we had a look at the IGSS data server. So at the overflow, we used the suggest function in PV find ADDR. We're going to do the same thing using Mona, and we'll just look at the output and see what it looks like today. So, quick video. So we load the application, it's running. We're basically going to do the same thing. Attach the debugger. Okay, it's running. First we'll set the configuration. So we'll write all the output, and we've defined the working folder to a separate file, to a separate folder. We'll create a pattern PC. See, shorter instruction saves us a few milliseconds of time. And of course, yeah, the pattern created will be exactly the same. So there's no change there. We just copy it. We paste it again in the same framework. Save the file. Yeah. And we'll double click, boom, application crashed. Okay. So you're going to run suggest. It crashed with a cyclic pattern. We should get a lot of information. So the actual search takes about the same amount of time. It took 6.7 seconds, and let's see what it gave us. So basically the same information. And if you pay attention to the end, it says length. It actually shows you the length of the pattern now. It didn't do that in PVE. So, and the output is Metasploit friendly. So we don't have to look for a pointer anymore. It already provided us with a pointer. It shows us the offset, and it actually shows us the exploit section, which you can simply copy and paste into a Metasploit module, save the file, run, and it will work. So that took 6.7 seconds. I think that's not bad. Yeah, I'm not going to copy it to a Metasploit. I mean, we've seen the results. So the find functionality, we also improved it. I think one of the most important new features is looking for pointers to pointers. If anyone of you ever worked with a function pointer override, vtable, you'll probably end up with a search to find a pointer to an instruction. So Mona can do this now. And if you, for example, it's just a hypothetical case, if this is the piece of instructions or the instruction that will lead to EIP control, and if you control the location referenced by ECX, if you want to get access or if you want to override EIP based on the flow, we'll need a pointer to jump ECX. That's simple. So using this simple command, and I'm now limiting the search to just one module, but of course you can just search the entire memory space. It's going to give you the list of pointers that will point to a pointer that points to jump ECX. If you have to do this manually, good luck. You might as well take 2 weeks of holiday. It's not even sure if you will find it. So it just takes 2 minutes. It's not that bad. Some other nice goodies. Breakpoints. You can actually set a breakpoint on a certain memory address and trigger the breakpoint on a read, a write, or an execute. It's not 100% stable, but it's still using the IMLib, and I think there are some issues with it, so I'm going to work with the guys from Immunity and see if we can solve this. File compare, that one is going to allow you to compare the output of a Mona search, a given search. Suppose you ran the output on an XP system, English, you run the same command on an XP system, French, and you want to find the pointers that match. You basically do a file compare, you feed it to 2 files, and it will show you the matching pointers. So that's also quite handy. Egg will allow you to not only show you the bytecode required for an egg hunter, but if you actually feed it a file that contains shellcode, it will produce an egg hunter that has a checksum routine for that shellcode. So you can actually make a reliable egg hunter with this code. Byte array is just a function to create a byte array that will help you to find bad characters. And header, I couldn't find a good name for it, but it will basically do this. Let's say there is a file, you open it in a hex editor and it looks like this, and when you're writing your exploit, you really want to know what's in there, so you just run header against it, and this is what it will output. And it's kind of smart, it will show you ASCII. If it finds bytes that are repetitions, it will just say null byte times 12. So that's kind of what it does. Nothing spectacular. And finally, I spent about a month working on rewriting the ROP routine. It was slow. I'm trying to save time here. It was slow, so we had to work on it. We had to increase the options. There is now an optional separate stack pivot search where you can say this is the minimum and the maximum value that we need for the stack pivots. It can read gadgets that were already created. So if you produce a gadget file for a specific module, it can read the file and use it as an input, so it doesn't have to search for memory. That's also kind of nice. And the generation process looks like this. So it does a search in memory of files, looks for gadgets. It's going to create a gadget file, rob.txt. Based on that file, it's going to look for stack pivots, unless you were looking for stack pivots in the first place. It's also going to create suggestions, which are, based on my experiences with all the ROP exploits that I've seen and that I've written so far, are the instructions that I feel are the ones that you are very likely going to be using when writing your exploit. So that file will contain only those gadgets, and they will be classified. So you will be able, and I'll show you, I have a demo on that, so we'll look at that. ROP_func is a file that will contain pointers to interesting functions. It's going to do a search and see if there is a way to find reliable pointers to, for example, virtual protect. So it's going to show you where they are and how we can reach them. If you take suggestions and ROP_func, you should be able to build a ROP exploit in no time. So that's kind of nice. But I was thinking, well, what if there was something like this? Drop the builder. Would it be possible to have it build a ROP chain? Yes, we can. Mona offers ROP automation. So it's actually going to build the entire ROP payload. So you can copy and paste it and it will work. So it will just look for the gadgets. It will gather all the gadgets. It will take the ones from the suggestions. It will take ROP_func, put everything together, build a exploit. So let's look at a quick demo. This is the command, by the way, that I will be using. It's the only command that I will use. So, a bug in Wireshark. If Wireshark is set to be listening on the network and you broadcast a specially crafted DECT packet, you broadcast it on the network, it can trigger an overflow. This is, by the way, this is a Vista machine. It works on Windows 7. It doesn't really matter. DEP is enabled. So I'm just going to show the process. Now, I have to be honest, I cheated a little bit. So I just cut out the time that it needs to process or to generate all the gadgets. So if you see the screen blur, that's just the time that I cut, and it will then show the time that it actually needed to produce the results. So we'll just take a look. So it now already found 25,000 gadgets. Now it's going to apply all the logic. Okay, and we're done. 5 minutes. Well, it used to take 2 hours to do exactly the same. So let's look at the output. So the stack pivots, if you look at the stack pivots, it's smart. It's not going to just look for add ESP something, but if there is like an instruction in between, like an XOR or something else that doesn't break it, it will just allow it and it will see the entire instruction as a stack pivot. These are the suggestions, so you can see that it categorizes them. It actually says, see, if you want to add something from one register to another, these are your options. to move something from one register to another. And it also creates this, a Metasploit, Rob gadgets. It automatically filled in everything, so you can just copy this, which is what we'll do. We'll go to a backtrack machine. So this exploit is in fact part of Metasploit. I'll just edit the Rob gadget part. I wrote that one manually. I didn't have Mona. And actually, if you look at the size, well, we'll just delete this, paste what Mona created, and you'll see that it's actually 70 words shorter. So Mona is smarter than I am, and she's only 6 months old. So we'll just save the file. And we'll set up MSF console. I cheated again. I already set up the fact that I was going to use that particular exploit with all the payload options. I'm going to use a reverse meterpreter. And in the meantime, I just closed debugger. I'm just going to configure Wireshark to listen on the network. So it's just sitting there. It's just sniffing in the meantime. Metasploit returned. So we see all the options. The interface I'm going to use to broadcast the packet. This is the payload. This is the IP of my Linux box. Exploit. That's it. So bypassed ASLR and DAP, and it took 5 minutes to do that. So. And yes, we can run calculator as well if you want. So I think this hugely improves the entire process of building exploits. I have to be honest, the Rob generator, it's not going to work in 100% of the cases. There might be reasons why it's not going to work, but at least with the information that it provides, it will buy you a lot of time to actually build your exploit. So if you just need to fix some fields, you just can take a look at the suggestions file, and in most cases they will contain the gadgets that you will be using to complete your exploit. So. Conclusions. PV find ADDR is dead, but there's a new one. And a big question, when can we see it? Well, I got good news for you guys, because I am going to release it tomorrow. So if you keep an eye on Twitter or just have a look on the website, there will be an announcement sometime tomorrow that, well, if I manage to get out of bed tomorrow morning, so it should be online. Thank you guys for attending. This concludes my talk. Any questions? Any questions before you guys can take a coffee break? Yes, question over there.
What kind of abstraction do you use to perform gadget selection and to understand that this sequence instruction will indeed a copy and not EX into ECX?
Well, in fact, it's that particular technique to build the chain is a technique that uses push AD at the end. And if you look at all the exploits, it's really simple to do. So there's no need for complex abstraction or an intermediate language. It's simple. Just look at what it generates, and you'll see that you really don't need a lot of knowledge to be able to build that chain, because most of the instructions are just pop something into a register. You'll see. There's nothing really special about it. It's so simple. Okay? Questions? I saw a second hand, I felt. No? Okay, well, thanks again.